Good morning, good afternoon, whatever time of day it is you're watching this video, good that. Okay, we are taking a look at Amonton's law. I'm going to review questions number 4 and number 2 on this week's worksheet. Just make sure that you kind of have the gist of everything. Of course, as always, reach out to me if you have any questions. On this law, and I want to remind you with any gas law, you have to convert the temperature to Kelvin in order to use the expressions. And some of these questions even ask you for temperature in Celsius, and you still have to convert to Kelvin to use the expression and then convert back to Celsius at the end. The reason being for this is the conversion process between Kelvin and Celsius is not a multiplication or division factor. It's an addition-subtraction factor, which does not cancel out if you don't correct for it. So just make sure that if you're using the expressions, you should be, if you're using these expressions, that you have your temperature in Kelvin, but to pay attention because sometimes they want you to convert back. Okay, cool. So let's take a look at number 2. I'm going to read it to you. A lot of times when I screen share, my mic messes up a little bit, so it would be great if you have your worksheet out in front of you and you can follow along as I read this. So on number 2, a gas has a pressure of 0.37 atm at 50.0 degrees Celsius. What is the pressure at standard temperature? Okay, so our first job always is to identify our variables. As I've told you, I would typically give you these worksheets in class and have you circle any number and label it in the problem. As you can see, everything's a little different right now. So if you're working these on just scratch paper, I would do this just as I have done here. If you print out the worksheet, then feel free to circle those and just label your variables there. So let's start off. The first value given in the problem, gas has a pressure of 0.370 atm. So that's going to be our P1, 0.370 atmospheres. Okay, our initial temperature is 50.0 degrees Celsius. So we're going to add 273 to that in order to convert. 50 plus 273 is 323 Kelvin. Okay, and then it says, what is the pressure at standard temperature? So our P2 is our unknown. I like to put a question mark there. And then our T2 is standard temperature. If you'll remember, standard temperature is 273 degrees Kelvin or 0 degrees Celsius, but we don't care about that again because we need to use Kelvin. 273 K. Sorry guys, my phone. Okay, so we are solving for P2. If you look at this equation, put your finger on P2 and whatever else is on that side of the equation is what you're going to divide by. So T1 is what's going to be in the denominator here. So it'll be P1 T2 divided by T1. Okay, and then we plug in our values. I'm going to angle my camera a little bit more so you can see. You can see my exercise equipment back there. Sorry, you guys. Okay, so our P1, 0.370 atm. And then our T2, 273 Kelvin, all over T1, which is 323 Kelvin. You'll notice K cancels. You're left with atmospheres. You multiply across the top, divide by the bottom, and round for significant figures. Each of these values has 3 significant figures, so we're going to round to 3 sig figs. So you should get 0.313 atm. Now let's evaluate. We know pressure and temperature are directly related. You increase temperature, you increase pressure, and vice versa, okay? So let's look at what happened to temperature and evaluate if our answer for pressure makes sense. Our initial temperature was 323 Kelvin. Our final was 273. It decreased by 50 degrees, right? So our pressure should be decreasing because our temperature is decreasing. So let's see if that happened. Well, our initial pressure was 0.370 and our final is 0.313. Yes, it decreased. So it did what it's supposed to. That's good. We should evaluate our answers as a way to check them before we submit. Okay, so there's number 2. Let me know if you guys have any questions on that. All right, next, number 4. Again, I'm going to read it and you follow along on yours. If a gas is cooled from 323.0 K to 273.15 K and the volume is kept constant, what final pressure would result if the original pressure was 750.0 millimeters of mercury? So there's a few things that we need to pick apart here. That piece that says the volume was kept constant, we're assuming that for every problem on this worksheet because volume doesn't appear in this expression. Volume, we're assuming, is not a factor. So that is excess information. We're already making that assumption for this worksheet that volume is kept constant. So that is extra. The other thing is they're using millimeters of mercury as their unit of pressure. And don't let that trip you up. It's just a different way to express the same information for pressure. So let's identify our variables. Temperature changed from 323 to 273.15. So my initial temperature, 323, make sure I get my decimal one right. Okay, 0.0 Kelvin. Hey, we didn't have to convert on this one. They gave it to us in Kelvin. Awesome. All right, next. 273.15 Kelvin. You can see we're going to keep lots of significant figures in our answer. Okay, so it says the original pressure was 750.0, yes, 0.0 millimeters of mercury. Okay, and then it says what pressure would result. So our question mark is P2. All right, we don't know our final pressure. So again, we're solving for P2. We're going to divide these guys by this one. P1, T2 divided by T1. We plug those values in, and I'm going to go ahead and just give you the answer here. You plug in those values to this expression, and you're going to end up with 634.2 millimeters mercury. And I just realized that for both of the ones that I did, you were solving for pressure too. So I'm going to go ahead and pause my video, erase my board, and we're going to do one more where we're solving for a different variable. That was an accident, so forgive me. Okay, so let's take a look at number 3 as well. So we ended up doing 2, 3, and 4, but that's okay. So if you look at number 3, a gas has a pressure of 699.0 millimeters of mercury at 40 degrees Celsius. What is the temperature at standard pressure? So let's identify our variables. P1, T1, P2, T2. So our initial pressure, 699.0 millimeters mercury. Okay. Our initial temperature, 40.0 degrees Celsius. We need to add 273 to that. And you end up with 313 Kelvin. Okay, that's your T1. Now I chose this one because it says, what is the temperature? So our question mark is T2 at standard pressure. So usually whenever we're talking about standard pressure, our kind of gimmick is just to use 1 atmosphere because math with the number 1 is really easy. However, whenever we're using different units of pressure, we have to, or we're told standard pressure, we have to choose the unit that matches the unit in the problem. So if we were to use 1 atmosphere here, our units wouldn't cancel in our final answer. So we would have kind of an apples and oranges situation. So we need to choose the unit of pressure for standard pressure that matches the one in our problem. So remember, standard pressure is 1 atmosphere, 101.3 kPa, 760 millimeters of mercury, or 760 torr. So we're going to choose 760 millimeters mercury because it matches and we won't have to convert anything, which we like. Okay. So if we are solving for T2, we're going to divide by P1. So it will be P2 T1 divided by P1, and then we plug in those values. So 760 millimeters mercury. Sorry guys, it's messy. Okay, there is our P2, and then we need our T1, which is 313K. And then we're going to divide all of that by our P1, 699.0 millimeters mercury. Okay, again, forgive me, it's messy. Okay, So we multiply across the top, divide by the bottom, and then round for significant figures. So you can see the 313 is what's going to limit us. That has 3 significant figures. So our answer needs to contain 3 significant figures. So it's going to be 340, and I'm going to just do a decimal point after that 0 in order to make it significant. And that's going to be K for Kelvin because millimeters of mercury cancel. I'm going to go back to that. So here, the reason why our answer is in Kelvin is because millimeters of mercury appear on top and on bottom of this fraction, therefore making them cancel. I wanted to highlight this because, again, when we were told standard pressure, we chose 760 millimeters of mercury in order to make these things cancel here. If we didn't choose that, our units wouldn't cancel and it would just be a mess, okay? So again, let me know if you guys have any more questions. Have an awesome day. Miss you. Hope you're staying well.